Right. Sieve tube, companion cells, phloem parenchyma, sieve cell. Just wait 1 minute. First, sieve cells. So, like a tracheids, xylem cells like a tracheids. In xylem, like a tracheids, sieve cells are present. Actually, sieve cells, they are included inside the sieve tube. Almost look like a trachea. The sieve cells look like this one. Cell, sieve cell. Sieve cell and sieve tube both together called as sieve element. First, let's discuss about the sieve cell. These are narrow in structure, like a trachea, and linear with ends, with the pointed ends like this. Here the pointed ends, and here also pointed ends. And these the sieve cells are joined end to end, end to end. Here the one sieve cell, and again joined to another one, and again another sieve cell like this. End to end, joined end to end like this. Where there the walls and walls are overlapped. For example, this is for example sieve cell, and another sieve cell overlapped like this, another one overlapping like this. So this overlapping arrangement, one above the other. And the sieve areas are sieve-like walls are areas with pores. And here the sieve areas, for example, these sieve areas are with pore like this. Sieve areas, pores, through which protoplast of adjoining cells goes toward the adjoining cells, which are interconnected like this. The pores in sieve areas are narrow. Like this, the narrow means, for example, this is the connected, the pores like this arrangement. Actually, mostly they are this type of arrangement mostly presents in lateral walls here. This lateral walls. Of course, this parallel overlapping nature. This is one sieve cell and another sieve cell like here. For example, this is the first one. Maybe arrange one above the other, another or another overlapping like this. This type of overlapping also there. And this is the area where sieve plate is present. Simple. This may also present and this may also present. The mainly this type of arrangement mainly appear in gymnosperms. The present of lateral walls, the sieve plates that is mainly found in gymnosperms and also pteridophytes also. The important difference between the sieve cells and sieve tube we will discuss later. Uh, and sieve cells are an important components of phloem in the lower vascular plants and gymnosperms. Already told you it is similar to trachea. Tracked also same structure. Tracked also same structure. But here in phloem cells, we can see the clear nucleus. But in trachea, no nucleus. And with cytoplasm, in trachea, no cytoplasm. The same both ends. But here the sieve areas are present. But trachea only vessels in vessels areas are present. And one above the another in areas the arrangement of these pores are present through the pores protoplast movement, the food material transfer for one cell to the another cell, and this mainly present in pteridophyta and gymnosperms and also angiosperms, but majorly mainly perform to food conduction in lower plants like a trachea. The next one, sieve tube. All you can imagine the sieve tube like this is the sieve tube. The between it is between sieve cell and companion cell. The sieve tube is a series of sieve tube and connected end to end in vertical rows. So this is one sieve tube, and again above another sieve tube. Here also another sieve tube present, like a sieve cells. Same sieve cells also like the top arrangement. And here also same. Here the sieve plates are present in between one sieve tube to another sieve tube. This is the sieve plate. It's the sieve plate. The sieve plates present highly specialized sieve areas. These are the sieve areas with relatively larger pores and restricted to specific region. When compared with cells, smaller, but here the larger pores are present. The sieve tubes in the phloem are the counterparts of vessels in the xylem. Same, already told you. This is similar to xylem, vessel. Now let's discuss in clear view of the sieve plates here. Let's change the later we will discuss about the companion cell. Let me complete the sieve tube. In sieve tube, another important, the sieve plate, major one. Sieve tube, right. So far we completed. So far, just wait. So far we have completed about the phloem elements such as sieve cells. This is sieve cell and sieve tube. Both are called as a sieve elements. And the difference between sieve cell and sieve tube. Here the sieve cells some elongated and tapering ends, but in sieve tube no tapering end. No, there is no tapering end, and both arranged one above the another. This is one cell, another above another cell, and also parallel arrangement mainly found in gymnosperms and pteridophyta. But sieve tube arrangement one above the another. The both separated by the sieve areas, which is consisting the uh, pores, but clear sieve plate present in sieve tube. This is the sieve area, sieve plate, and sieve area with larger pore. Sieve cell also have the pore but smaller. But in sieve tube, larger pores are present, and these are interconnected one to another. So this is about sieve elements. The next one, companion cell and phloem parenchyma. Before going to the explanation about the phloem parenchyma companion cell, let's in detail discuss about the sieve plate. Right. Let's see about the sieve plate. Just wait. Right. Right. Correct. Right. Now let's discuss in detail about the sieve plates. The sieve plates are mostly confined to the end of the walls. This is the end of the walls of the sieve tube. And this is, for example, let me take the pen. This is one sieve tube cell and this neighboring another sieve tube. The sieve, both sieve tubes by sieve plate. This is the sieve plate, right? Sieve plate area. So the sieve plates are mostly confined to the end of the wall. This is the end of the wall. And it is aligned with transversely oblique septa. The sieve plates are distinguished in two types on the basis of number of sieve areas. They are simple sieve plates, and compound sieve plate. First of all, let's see the simple sieve plate, wherein in simple sieve plate, right? In simple sieve plate, one sieve area is present. Example in your book given cucurbita. And compound sieve plate, wherein may discrete sieve areas are present. Vitis, spiders, smallest, some of the examples. It look like in vessels also simple and simple pore and compound pores present. Same like that here also the simple sieve plate and compound sieve plate. For example, simple sieve plate means at the end of the wall only one pore present. If it is one pore is present, that is the simple. Like number of pores like this, the number of pores are present. So this is called as a compound sieve plate. In this diagram, we discuss about the compound sieve plate rather the simple one. The sieve plates are characteristic of the angiosperm phloem. These sieve plates mainly, actually, why? Because angiosperm, because the sieve tubes only present in angiosperms, but not found in the pteridophyta and gymnosperms. Like a xylem elements trachea. The xylem element tracheids only found in the lower plants such as pteridophyta, gymnosperms, and also angiosperms. Xylem vessels only found in angiosperms, but not in the pteridophyta and gymnosperm, but very rare cases in some few plants, very few plants, vessels also present in pteridophyta gymnosperm. Likewise, here also, similarly, in actually sieve tubes mainly characteristic feature of the angiosperms, not found in pteridophyta and gymnosperm, but in rare of the rarest case, in pteridophyta members also, and gymnosperm members also having the sieve tube. The same example that is which has the xylem vessels present in Pteridophyta, Selaginella, Pteridium, Welwitschia neetum in gymnosperms. The same the Pteridium and Welwitschia neetum have the sieve tubes. So that's why the sieve plates are characteristic of the angiosperm phloem. They are comparable to the perforation plates of the vessels. But in vessel perforation plate, simple perforation plate and compound perforation plate. Here the same simple sieve plate and compound sieve plate, simple. Through the wide pores of sieve plates, the protoplast of one neighboring sieve tubes elements are connected in the form of connected strands, cytoplasmic stand. Let me take pen. Cytoplasmic like this. This is cytoplasmic stand. It's connected to one cell to the another cell, cytoplasmic strands. Clear. Cytoplasmic stand. Sieve tubes members with compound sieve plates are primitive were compared with the simple sieve plates. Here the simple sieve plates are advanced one. Right. A collos which is connected, which is present in the sieve plate area. The connected strands are the connection protoplast, neighboring sieve elements. Neighboring sieve element. The connecting strands are surrounded by the small cylinder collos, which is a carbohydrate that stained blue with aniline blue. The founding of this colors, whether it is present using dye, aniline blue dye. When we use aniline blue as agent, when it is converted into blue in color, right? The each pores lined with colors. For example, this is the pore. This is the pore lined with colors. Like this is colors stand. Cells colors. And here also this pore colors, colors. The red color stand colors, colors. Right? The colors accumulated rapidly in response to injury in the sieve elements. Where the colors increase considerably, it forms the colors pad. The depositions of colors increases during the inactive season and decrease in the active season. What happens if the colors increasing more? If the colors, if the color, this is the pore and colors, pore. What happens if the increase? What happens if the increase colors? The movement of what? The movement of food material the becomes less. Reduce the movement, right? So as the sieve elements, as more colors accumulated, and the pore gets constricted and more or less completely absent. So that is the colors percentage and formation of colors. Right? This is also important for short answer colors. Remember anyway, already you know for example, this is the sieve tube, similar structure to the vessel, and another one is sieve tube, but it is connected by septa, the sieve plate area. The sieve plate area may be simple pore or compound. If you take the compound one, number of pores are present. For example, this is the one pore, two pores, maybe two, and it is aligned with Carlos thickening. Simple, the blue color, Carlos, Carlos. Here also blue color, Carlos, Carlos. Just imagine when during the disease infection condition or yeah, any inactive state, what happened? This Carlos increase, Carlos pads. These are Carlos pads. This Carlos pad increase. What happened if the Carlos increases like this? There is the pore completely fused. Without pore, actually the pore tend to be the movement of the food material from one cell to another cell. If it is the excess of the colors, what happened? The completely the pore is fused, disappear. Now can it move to one cell to another cell? No, there is no movement. Even if move, it is very slow, very slow. They are the mainly appear in the older plants, right? So this is about a colors cells. And next one, sorry, companion cell, and also called albuminous cells. Companion cells. Right. So these are the companion cells. Let me take this is companion cell, or another name is albuminous cells. Mainly the companion cells also found in the angiosperms, but not found in pteridophyta or gymnosperms. Rare cases, in mainly they are found in some fewer gymnosperms also. The companion cells are parenchymatous cells and which are associated with the sieve tubes. Already you can see here that this is the sieve tube. This area, this is sieve tube. This one, the sieve tube associated with the sieve tube, and also they are the both are originated from the same mother cell. Same mother cell, one mother cell. This is which is divided after divided into two daughter cells. One daughter cells developed as a sieve tube. Another daughter cell developed as a companion cell. Developed as a companion cell like this. So companion cells, the companion cells retain the nuclei throughout their life. Of course, in sieve cells also have the nucleus, and also sieve tube also nucleus, but this nucleus present in early stage. But when maturity, you can see in diagram, in sieve tube there is no nucleus. In the sieve cell also later they are disappear. In sieve cells they are later disappear. But in companion cell, they retain the long period. The each sieve tube element is generally associated with one to many companion cells, like a other cells. The companion cells cannot be easily separated from sieve tube elements, as they are originated from the same other cell. The length of the companion cells varies considerably. They may be as long as shorter than the sieve tubes when compared with, of course, here they give the similar. For example, this is the one sieve tube from this year, one sieve tube, sorry, one sieve tube. But here the two component cell, one component cell, another component cell. That's why it is shorter, mostly half of the size. The walls between the sieve tube elements and the companion cells are connected with one another by means of sieve areas. Here also have the sieve areas. The lateral side also have the sieve areas. By means of sieve areas on the side of the tubes and primary pitch fields on the side of the companion cell. Already told you in the gymnosperms, no companion cells are present. Instead, albuminous cells which are present in Netum, Welwitschia, they are also readily stainable with the cytoplasmic stain. The main difference between albuminous cells and of the gymnosperms and the companion cells of the angiosperms, they are not ontogenetically related to the sieve cells as in the case of companion cells. And component cells and sieve tubes. So here the, for example, albuminous cells, gymnosperms, component cells, angiosperms. I already told you the companion cells and sieve tubes, the same mother cell. But in gymnosperms, of course, the albumin cells look like a companion cell. But in gymnosperms, the sieve cell and albuminous cells, they are not developed, they are not originated from the same mother cell. They are different. For example, if you take angiosperm, angiosperms have the companion cells, sorry, albuminous cells. This is one mother cell which gives the albuminous cell. And gymnosperms, most of the gymnosperms no receive tubes. This is another mother cell which gives to the sieve cell, sieve cell, give to sieve cell. Whereas in angiosperms, single mother cell divides and form one is companion cell, sieve tube, ST, sieve tube. That is the difference between the albuminous cells and the companion cells. Is it clear? And last one, xylem parenchyma. Last one, xylem parenchyma. The name itself given, sorry, phloem parenchyma. The phloem parenchyma, that is tend to be only the storage food material. And also lateral movement of the food material from one cell to the another cell. Right? This is the main function. And also xylem fiber. And another important, the phloem contains the parenchyma cells that are connected with many activities characteristic of the living parenchyma cells. Already told you, so the storage of starch, fat, organic substances, the tannin, resins also found in these cells. Parenchyma cells of primary phloem are elongated and they are oriented like the sieve elements. Same, polar parenchyma also same like a sieve element such as sieve cell and sieve tube. There are two types of parenchyma found in secondary phloem, whereas in primary phloem one type, but in secondary phloem two types. These are the vertical phloem parenchyma and horizontal phloem parenchyma. Right. So this is about phloem parenchyma and also phloem fiber. The last one you can see the actual not given here. The phloem fiber also present. It is look like similar to the xylem fiber. Remember it. In many flowering plants, fibers form the prominent part of the both primary and secondary phloem. The phloem fibers are rarely found or absent in phloem of living pteridophyta. The phloem fibers also absent in pteridophyta like sieve tube, companion cell. And they are also not found in some gymnosperms and in some angiosperm also. And actually, the only the simple pits are found in the walls of phloem fibers. The walls may be lignified or non-lignified. Already we discussed in commercial fibers in yesterday, the cannabinous fibers are lignified, whereas linum flax are cellulose and without lignin. The lignified less commercial and cellulose more commercial. Because of the strength and stand of the phloem fibers, they have been used for a long time in manufacture of the cuts and rope, mats and cloth. This also we discussed. The fiber used in the ways has been known since early times. Actually, this is already told you as a bast. That means the phloem fiber called as bast. So this is about the fibers, right? Phloem fibers also completed. Now in anatomy, the in first unit we already completed the about the tissues, and any other here remaining no. Next one, leaf internal structure and all internal structure, and any other missing here, phloem parenchyma, right, right, clear, almost all complete, right? Let's summarize once again. So far we completed. Let me summarize in brief. Unit 1. Already Unit 1 is completed. Meristems and tissue. Unit 1 completed. Meristems and tissue in Unit 1. Right. Already told you tissues, group of the cells. The tissues mainly two types. They are they are meristematic tissue and permanent tissue. Already told you meristematic tissue. They are the embryonic development. After formation embryo, from embryonic cell developed as a meristematic tissue. Later, this meristematic tissue divided and forms after division in the group of in the two cells. One of the cell act as a meristematic cell, another cell act as a permanent cell. Again, the meristematic cell divided, redivide and form again form permanent tissue. After formation permanent, here the increasing number of portion of the permanent tissue. If we separated the permanent tissue, first of all, the meristematic tissue have the capable of division. Permanent tissue lost the capable of division temporarily, but not permanently. Whenever it necessary, it can also capable of have the retain the division, capable of division. Right, in permanent tissue, there are three types: simple tissue, complex tissue, special tissue. Simple tissue, group of cells, same size, function same. Complex tissue, structurally dissimilar, function same. And specialized, they are all completely special. The function different, cell type is different. Coming to the simple tissue, in simple tissue again separated into parenchyma, collenchyma, sclerenchyma. Already the difference between parenchyma, collenchyma, and sclerenchyma among the sclerenchyma dead cells. And next one, complex tissue. In complex tissue, different type of cells are present and same function. Complex xylem elements and phloem elements. In xylem elements, tracheids, vessels, xylem parenchyma, xylem fiber. Same way in phloem, sieve cell, sieve tube, together sieve element, and companion cell, and phloem parenchyma, phloem fiber. After that, next one, specialized cell. Actually, specialized cells, specialized tissue, granular, different are there, but our syllabus gives the lattice tissue. Already we have discussed about the lattice tissue, right? This is about the first unit. And next one, that is internal structure, leaf internal structure. Now it is coming to the leaf internal structure. Uh, where is bad screen? Wait. Right, coming to the second unit, leaf internal structure. What is happened? In PPT will be shared in the screens of documents. Whiteboard in the share got 1 minute. Shared this meeting. Right. So leaf internal structure. In our book, given some of the very easy topics such as epidermal cell complex, epidermal cells. No need to write about the epidermal cells. That is not an important one. Specialized epidermal cell, stomata complex, distribution stomata. They are the very easy distribution. For example, amphistomatic, hypostomatic, epistomatic. Simple. For example, this is the leaf internal structure. If we take the leaf internal structure, two epidermis, upper epidermis, upper epidermis, and lower epidermis, upper and lower epidermis. The stomata present both surfaces. If the stomata present, let's change color. If the stomata present here and here, that is called amphistomata. Hypostomatic means the stomata confined to the abaxal lower surface. This is only here present, that is called hypostomatic. Epistomatic ear if the present at outer epidermis, epistomatic. So the stomata, these are generally the present with help of with the structure of the guard cells. Guard cell. If you take the clear structure of the stomata like this. So this is stomatophore. Stomatophore with the guard cells and subsidiary cells. The subsidiary cells. So this one, for example, this is the leaf. The leaf upper maybe it's the both sides or maybe one side. Both side amphi, lower side hypo, above side epi. Now the here the given the structures of the stomata types also. The stomata types. So this is the stomata. Okay, right. The different type of stomata types are there. First one anamocytic. Anamocytic. In anamocytic, in anamocytic stomata for guard cell, guard cell surrounded by more subsidiary cells. Let's change color. More subsidiary cells. One, two, three, four legs. This is called anamocytic. And another type of stomata is anisocytic. That means unequal. The stomata with the three subsidiary cells. Aniso. In aniso, stomata stomata with unequal three cells, small and another one large. So this is called anisocytic. And another one is parasitic. Name itself given parasitic means parallel. Guard cell, subsidiary, only two subsidiary cells which are parallel to the guard cell. Simple. That's it. And diacytic. And diacytic, same for stomata. Instead of parallel, these are in 90-degree angle. This is the one. They also two subsidiary, but 90-degree to the guard cell. That's it. Right? So anatomical structure also given dorsiventral leaf, isobilateral leaves, uniform leaves. You know already in practical training classes, you must have learnt about the different type of leaves, dorsiventral. What is about dorsiventral? Dorsiventral means dorsal side and the ventral side. And isobilateral means the leaf is placed in such a way the both surface receive an equal amount of sunlight. As they are in vertical, the leaves of cylindrical are distinct upper parts. So another one is unifacial. Unifacial means the leaves are cylindrical and a distinction into upper and lower surface opposite. Simple. For example, dorsiventral. For example, if you see the dorsiventral leaf, for example, this is the leaf. This is the leaf. The leaf arrangement like this. On the axis, branch axis, this is the branch axis, leaf axis, leaf like this. So this is the this side is the ventral side and this side dorsal side. So this is mainly present in the dicot laders. Whereas in monocots, the leaf like a arrangement like this. So this is called as isobilateral leaves. If you take the isobilateral leaves, the sunlight receive the both directions. That's the isobilateral. Whereas in this like only sunlight and dorsal side of it. And another leaf also given in our textbook, that is the unifacial leaves. If it is unifacial leaves, correct, this is the leaf, the round look like this. So this type of arrangement called as unifacial leaf. That means we expose only one face, outer face, but not inner face. Next one. And the best example to the unifacial, the already onion leaf. Onion leaf. Now the anatomy of dicot leaf. That means dorsiventral leaf. Anatomy of dorsiventral leaf. Simple. One minute. Xylem. Dicot leaf internal structure or dorsiventral leaf internal structure. If you take internally, the leaf already told you two epidermis, upper epidermis and lower epidermis. Upper epidermis cells, right. Upper epidermis cells are, just wait, copy image. Uniseriate and lower epidermis cells also uniseriate without intercellular space. The both are have the without intercellular space. And both covered by cuticle layers. It is not connected. Just 1 minute. It is leave 1 minute. Right. Dicot. Leave. Right. So this is the dicot leaf internal structure. The name gave clearly three regions. Three regions such as upper epidermis. This is upper epidermis, upper epidermis, upper epidermis, and lost this one, lower epidermis, lower epidermis, and rest of this is mesophyll cells. This is completely from this here the mesophyll. In this mesophyll, two types. This is palisade elongated cells. This is palisade cell. These are the this is spongy cells. You can see the difference between palisade and spongy. Right. So the dicot leaf generally dorsiventral already you know that it has the upper and lower unlike diagrammatically shown thus. This is usually made up of single layer. This is single layer and this is single layer mostly without intercellular space. That means there is no space between one cell to the another cell. And the mainly the cuticle on the upper epidermis is thicker. Here the cuticle you can see in diagram also. This is thicker. This cuticle. This cuticle layer present in upper epidermis and also presents in inner epidermis also. But in inner epidermis, cuticle layer thin, whereas the outer thick. The minute spores opening the found the epidermal cells called as actually nerve like this. In the nerve there, the pores are leave. This is called stomata. And these are more in number on the lower epidermis than the upper epidermis. As the dorsiventral side, the lower epidermis more, but in upper epidermis very less. The stomata already you know the stomata is surrounded by the pair of bean-shaped guard cells. These stomata open into the air. The guard cell contain chloroplast, while the epidermal cells do not. Here, in guard cells only have the chloroplast, but epidermal cell there is no chloroplast. Remember it. And the stomata useful for transpiration and gas exchange. The next one, the mesophyll cells. The tissue between the upper and inner epidermis, they call mesophyll. It has the two regions, namely palisade. Already told you, this is palisade. The palisade mainly one or two layers like this, one layer without intercellular space, and these are elongated cells inside the palisade. Chloroplast also present. And whereas in spongy, the large space present between the spongy cells, which is called intercellular space, and it's also consisting the chloroplast. And vascular tissue, the middle, this is the vascular tissue, the center called as vascular tissue. The tissue are present in the vein, the center present in the veins, ribs. The bundles are conjoint, joint, collateral, and closed. This is phloem, and this is xylem. And the phloem and xylem present, and this type, and these are arranged collateral, jointed, conjoint, and that's why it's collateral, conjoint, and closed type. If it is separated, clear meristematic tissue, that is open type. But there is no meristematic tissue between xylem and phloem. That's why it's classed as closed type. Xylem present toward the upper epidermis. This is xylem, upper epidermis. whereas in phloem toward the lower epidermis. And the bundles are surrounded by compact layer parenchyma. This is punctate layer parenchyma called bundle sheath. This is called bundle sheath or border parenchyma. Xylem consists of metaxylem. Vessels are protoxylem vessels. Metaxylem simple, for example, this is the first xylem, main. The other side, small xylem present. Protoxylem here. So this is called metaxylem. The protoxylem, the vessels are vessel present toward the upper epidermis. This is the protoxylem, and also lower epidermis also. The phloem consists, that means the protoxylem less vessels are present toward the upper epidermis. The phloem consists of sieve tubes, component cell, and phloem parenchyma. Just now we discussed. But in fibers absent. In leaf, phloem fibers are absent. And also same in xylem, also xylem vessels, xylem parenchyma, tracheids are present. But here also same xylem fiber absent. This is about the dicot leaf internal structure, right? Tomorrow we will discuss, in the next class we will discuss about the anatomy of monocot leaf. Uh, right. This is also very important for short answer. Dicot leaf and monocot leaf, and very easy. If you know the diagram, you just write based on the diagram. The very simple and easy. And you must have learned from the eighth standard. The dicot leaf, monocot leaf, they are the very simple question. No need to waste your time. Thank you all.